Assalamualaikum warahmatullahi wabarakatuh, and very good morning. Uh, welcome back to CATIA Camp training. So this is a tutorial on prismatic machining. We continue with this CAM models that is posted in Kailam, so you can go to Computer Engineering and Manufacturing course BTI 2412 and the CAM models. So you see, you have this several part 1, 2, 3, 4, 5. So I will start with this vice model. So we open CATIA. So in this CATIA, I'm using this one is 2016 version, but it's okay if you have a V5 R21. Just that this is software that I've been installed in my desktop. Okay, we open vice. So before we start, of course, we need to create the folder first. So as well we have been told before, you can do that by creating the um, uh, folder inside inside the folder that you want it to be lah. So for example, I create here vice. So I've done it twice here. So you can just create one folder over here and save it as for example vice 2. Okay, and then we can open the file. So if you want to automatically make everything in this software or in this program automatically save into that folder, you can change it into the in this tools options. Yeah, you can change it by clicking on the machining, and then you can make sure that your post processor and control emulator folder is set at IMS. So the path, you can leave it like that. So for two path files, NC code output and NC documentation location, then you can change this to the folder that you have just created here, right? So you can what I do is just control copy, and then press enter, and click select folder. Then you can do the same for the other line. And then this one, if you want to leave it like that, it's also okay, but I change it the name to a shorter code name. Right, so after you open the file, you will see that you have one vice, and then another one is the rough stock. So this rough stock is created by using advanced machining mode, but then it is not used in our tutorial today. So it was made under geometrical set. We are not using geometrical set for this tutorial, so I just delete it. Okay, and then I will save this part in next view, and sorry, in the new folder. So I set it as vice 2, and I save I save the cat part into that folder. Okay, now we continue with the tutorial by creating a new body, and this new body should be named as stock. So this stock part is the material that is to be used as our initial workpiece before we machine it into this shape, right? So before we create the stock, we need to select a plane. So this plane is being selected, and we go to sketch, and then I will create a box, just a simple box. You can determine the initial dimension, of course. You can do that. So this is simulation of the real cutting. So is if you have a workpiece this big, so we can look at how big it should be. So I think 170 as for the length is okay, and how about the width? So I think 150 is good, so that we don't need to cut a lot more materials just to waste it on removing. Okay, so we will remove this part at the end of the day, right? Because we want to uh, machine it into this shape. Okay, this purple or this pink shape. Okay, so after that I want to make sure that this is these two lines are parallel with each other. So I'll just um, oh sorry, it should be parallel between these two. uh, so I will set it parallel. Wait, it should be symmetrical. Oh, sorry. So I will choose these two line first, and then lastly this horizontal line, and then only click the constraint division button, and then I click on symmetry. So same goes for the horizontal line. So the last line, and then this button, and then symmetry. Okay, click OK. After doing that, my sketch is already finished, so I can exit the workbench. Then what I need to do now is to project the sketch into a solid. Okay, so I project it. The okay, this is not the correct direction, so I can click on reverse direction, or you just click on this line also can. So we just create another in the different direction, so you can do that again. So now the thickness of this material is 15 millimeter. I want to change that into thicker material. So let's say I have for example standard bar would be 20 mm. So we have a 5 millimeter, so we have 5 millimeter extra material to be cut. So this is as good as possible the the actual machining. Okay, now we have the part, and the part that we want to be machined, and then the workpiece, the original workpiece, the initial workpiece, which is stock. So if I want to make sure that I can see my material, I can then increase this transparency and click OK. Okay, you see now our material. Okay, now because I selected only the surface, then it changed the should not be like that. It should be selected all together. So alternate E, and then alternate enter. Then I increase the transparency. Okay, now I have all my stock workpiece being transparent, so you can see the material that I want to machine. Okay, now we can also add something. So if you want to know what is our final product weight, so we can do that by firstly we select stock, and then we define a material there. So I want to put it as for example aluminium first. Yeah? Okay, click OK. But then don't forget about our vise. So our vise has no material yet, so I click on vise, and then I put it as in work object, define in work object, and then click on material, apply material again. So I click aluminium. We must have the same the same material. Okay, so this is just to know what's the material features before and after cutting. So if I want to look at what's the properties, I can do that. Yeah, I can do it here, for example. Okay, I can do it after I simulate the machining. Alright, so now we need to we need now send this part to machining. So we will create machining process by using prismatic machining. Okay, and now inside this window, now we can start with the machining process. So firstly we have this tree PPR. process operation, and then we double click on part operation 1. So now we have this window. What we need to do is firstly define the machine. Okay, now the machine that we need to use is just a 3-axis machine. And then next we need to check on the numerical control. So if this is not specified yet, you have to close this and go back to tools, options, and set it in the machining. Set in the machining. Okay, come back. So I have this part operation. Click on this numerical control. Post processor, you have to find FANUC. So should be FANUC 0 or FANUC 15C, but we don't have FANUC 15C, then we can use FANUC 0. And then for the NC data type, we have to use IMS PP table, because we choose IMS in the tool option machining. And then NC data type must be ISO. So after setting all these three, you can then click OK. Next, we have to create a machining axis system. So this point, okay, this is where our machine should be imagined. So normally, so you have this global axis, right? So normally, y-axis, x-axis is on this side. So y-axis in this side and x-axis in this side. So our point of reference for where the machine should take as the 0 point, it should be here. Okay, and then you click OK. If you want to change that point to the other way around, it is okay, but then you have to be careful with the direction of this x and y axis. But then of course the point is this default reference machining axis for part operation must start at this edge, at this corner. You cannot start it here, because that means that our tool will then start from here. So that is wrong, very wrong. So the cutting tool will then hit with the workpiece or the table. So that is not correct. So it should be above the workpiece. So the minimum point is somewhere here. So if you want to change this arrow to this reference axis to here, can do that. So you just click on that button again. So click on this center point. So change it here. But then you have to be careful. You have to make sure that X and Y is into the workpiece. So what we do? We come to this axis X, the green line here. So click on it, and then just click on reverse direction. And then you click OK, and then you click OK again. So you see the point now pointing inwards, towards the workpiece. Okay, so I choose this point instead of that at that point. Then what I want to do is I want to select the design part. So our design part must be our vice, and then our stock part is our stock part. Alright, and then after that I don't have any other option to select, so I'm just click OK. Okay, now we have selected the material to be machined. What I need to do now is to start the machining operation. So I click on manufacturing program 1. So if you want to change this machining 1, for example, vice milling, vice machining, because we have also drilling here. So you can just click OK. Now we start with the first section of machining, which is facing. Okay, we want to reduce this 5mm thickness, so we have to choose facing. So I click facing, and we have this tool change 1. Okay, so before we change the tool, we can start by clicking on the selecting the plane. So this is the top plane, so we don't have any other top plane. The only top is this plane, so just click on that. And then this is the workpiece plane. So not workpiece, the part plane. So I want to hide this workpiece first, and then I click on the model. Alright, and then I need to go to the change tool. So I have to change this to face mill. Okay, so the face mill we have is diameter 50. We can change that by looking here, but we don't have any other face mill size other than 50, so you can just use it. If you want to make it bigger, you can just look at for example, I have 56 mm in our workshop. You can do that, but the RC angle, yeah, you can just leave it like that. And yeah, so you see, when you change it, automatically it will change to T1 face mill D56. If you want to delete this face mill at T1 number, you can just leave it as face mill D56, and then change it here. You see, to change 1 face mill D56. Okay, and then next we go to this toolpath strategy, because okay, this is because this is a big so if I want to show our workpiece, so this is a big square, so I want to use a strategy where the milling tool will move to back and forth. Or if you want to change it to one way, so we start from here, so we'll go here, up here, and then up here, and then come back here, up here, come back here, up here, come back here. So we can also do that. But normally we'll use back and forth, but then today I will choose one way. And then for radial and axial, I will choose axial first, and I change to maximum depth of cut. So because we are doing roughing, so I will choose 1.5 millimeters our maximum depth of cut. And then for finishing, I will choose finish bottom only at 0.5 mm. We'll then look at we can look at the video afterwards, but before we do that, we go to radial. I think this one is yeah, just leave it tool diameter ratio first. We go to the approach and retract of the cutting tool, because our cutting tool will be put here as our starting point before cutting. So we want to make sure that when the when the tool is being called here, it should be called properly, and not when it moves, it does not do a diagonal movement, and we won't hit the workpiece and damage the cutting tool itself. So I think you can change it to axial, or if you want to use other thing like horizontal axial, then you call it from somewhere far, and I think it is better I use axial. So I use 50 millimeter, so the cutting tool will be caught and it will be hanging 50 millimeter up there. Okay, and then activate this point, and then for retract, I will also use the same one, axial. After it's finished cutting first, we go back here and retract at 50 millimeter. Okay, then let us look at the video. Will it yeah, see, now the cutting is not correct, so we have to change this back one way into back and forth maybe. So let us look at this. Oh, okay, yeah, it does not create the correct one, because I think this one is good. I didn't change this contour, so I need to go back to this plane selection. So I click on this contour, remove it, and then I have to click on it and click on the click on this default reference machining. Okay, and then it should be click OK. Where's the button? Alright, this one. Okay, then let us look at the process and look at the product. Okay, so this is the product thickness. So you can measure it. So click on this analyze button and then go to measure. So you can go here and measure the thickness. Thickness to here. Okay, that is not correct. Yeah, maximum distance 50 millimeter. I want to this two. This got not correct. So it should be 50 millimeter lah. So from here to here. You have to click on the line carefully. Yeah. It is not correct. Okay, I think this one. It is 90 degree, but the maximum distance is 15 mm. So just now I got 15 mm, but then why this not correct? We have to change the position. Yeah, so we got the distance 50 millimeter. Okay, so then I click cancel and then come back here. Alright, so we have start with the first facing operation, and we can see that the workpiece is done correctly. Next, what we want to do is remove this extra material and create into the hexagonal shape. So to do that, we have to create profile, so contouring, and yeah, I can hide this one first, and the surface that need to be done, it should be starting from here, and then we go to the right, because our default reference machining is here, so we do counterclockwise direction, and then double click on the surface. There should be button there. For 2016 there's no button. You can just double click on the empty surface here, and then this one is the bottom part, right? And then you see you have bottom there, and then tool axis is towards upward. Okay, next the cutting tool that we have to use is of course end mill, and I think 15 millimeter is good. I changed it to by clicking on this magnifying glass, and then look in mill and drill starter set, and then I choose 1105 or end mill D15 RC0, right? And then mill D15, I think this one is good. Now I want to change it to one way again. In the toolpath strategy, direction of cut, okay, climb cutting, step over, radial first, number of path, I think I can set it to 4, and distance between path, because this is 15, I create it as 15. Maximum depth of cut, I think because we want to have a roughing process first, so I can let it to be 2 lah, 2. And then for the finishing, so I set finishing bottom only. Bottom only is down here, so you want to put finish at last level and bottom, so means that last level is this side and also the bottom one. So I don't want to have any burr on there. I think you can set everything to be 0. So course the approach, you can create the same one, circular horizontal axis. So it comes from there, come here. Or if you don't want to have a movement like that, then you just use axial, and I use 50mm again. And for retract also I use the axial and activate this. Okay, now we can watch the video first. So okay, now you see it is in a wrong direction, so we have to change the direction toward outwards. So just repeat that. Why is it not correct? Okay, that is wrong. One way. Yeah, okay. So you have to. Alright, so let me show this thing. Show this thing first, okay, and then we can replay it. So you see it starts start here and finish here with 1, 2, 3, 4, 5. 1, 2, 4. So it rotates again because we have a finishing number of pi selected is 4. So because our diameter of cutting tool is 15, I think I can reduce it to 3, and maximum depth of cut is 2. Let's see how much can get. But then I think maybe this one will be left. Yeah, no. So nothing is left because the cutting tool that we choose is bigger, is big. Alright, so I have the correct hexagonal that we want. Okay, we can also measure it if you want, I think, but this one is okay. So I think let's finish our second step. Next, because I want already have the hexagonal, I can then hide this stock. Maybe hide it here. Okay, so what we have now is the next machining process, which is create the hole. So the hole must be created by using a drilling process. Okay, so by clicking on drilling, you have this window open. Now click on the top surface, then double click on the empty surface, and then this line, you have to click on the line of the hole, double click on it, and then this one is the bottom surface. And then what you have to do now is okay, so you can define whether the extension should be blind or true. So I want to have a true hole, so I click on true. Next, change the tool. So the tool we need to use is a drill bit, and the size should be 15. So we have to change it to D15. D15. Okay, and then click OK. So you have drill D15 here. So you have to change it. You see drill D15 there, and then you go to this cutting strategy. Power, okay. Appearance, change depth mode to by shoulder and breakthrough to make sure that there is no more burr or crown down there. So next, yeah, this one leave it first. So for approach, still I want to use it. I want to use axial. So I create this as 50, and for retract also I set it as 50. Okay, and then click on video. I want to check whether the hole is created correctly. Okay, so it is created correctly, and then click OK. Next, how to create this slot. So firstly we have to create a hole, drill a hole, and for that reason I want to create again a drilling pattern, and again this one is should be there, and then the hole must be on these two curve. Next, again the bottom part is there. You don't need to have a blind, a blind, so you create it as true. And then for the tool path strategy, it remains as the same. For drilling bit, the size is again the 15, the same size, and then approach, yeah, should be the same as previously. So you can then look at this, yeah. So you have the first two hole for the slot. Click OK on that. After that, to create the slot, you have to select profile, okay, and then the profile contour is then this one, this contour. So we have to start with this one, this line. So that is the finishing line, and then this one is the bottom part, so it should be down there. Next, we have to change the tool, and it cannot be a drill bit anymore, and it should be end mill. Now the end mill must have a size of 15 or smaller. For this, I think we could use end mill D8, maybe, for example. Use D8 first, end mill, and then change the path into zigzag, zigzag. So we go back and forth, until finish. So the distance between path should be 8. Number of path, I think, can be increased up to 6. Look at it afterwards, and then the maximum depth of cut can change it to 1. So for the finishing, I use the same one. So let us look at the video. So the approach and retract should be the same as previously. Alright, so this one is wrong. Okay, that is not correct. Let's look at the yeah, I think that is correct. So some error there, but our part is still produced as what we want. So that error is contributed by the fact that this is not connected to a license sources. Okay, so this is not available in the file, but it's okay, as our part is already created as what we wish, so we can have the NC code afterwards. So, okay, so you see you have 1, 2, 3 and 4 times tool change, but of course the processes uses 1 times facing, 1 time profile contouring, 2 times drilling, and then the profile contouring. So this one contouring is using end mill, and it is not the same size as the first contouring of the hexagon. So you see we have 1, 2, 3 and 4 types of cutting tool, different cutting tool for different machining operation. Okay, and if you want to watch the video, you can start with the video simulation using the tool path. Just click on it, and then you can click play, and you see this is the final product of our part. So firstly the milling process, and then the contouring, drilling, and then lastly Okay, so with that, we can right click on bias machining and um, download the or generate the NC code. So by clicking on the generate NC code, you have this in and out. Go to NC code, fun 0 is okay, motion is okay, and then in and out, programs, NC code by program. So this is the this is the folder that you have created just now, and then only click execute. So enter program number, it doesn't matter, just click continue and click OK. So if you open this folder again, you have this cat nc file, and you can try open it with you can open it using why it's not there. Yeah, you can open it using notepad or wordpad, doesn't matter. So this is the file of the cutting process. So it has a very long line, so this is not 211 lines, just maybe 20 something lines, or sorry 50, sorry 70, yeah, it is about 200 lines, 200 lines, 211 lines. Okay, and then you have this separation of face milling process, facing process, and then profile contouring, and then next is drilling. So you have drilling 1, and then drilling 2, and lastly the profile contouring for the opening. Okay, so with that we have finished creating our vise, and that is how you create the NC code that it can be transferred to CNC machine, and then call the code again in the NC machine and recheck it before you run the machining process. Okay, with that, thank you very much for listening, and Assalamualaikum, goodbye.